If I asked you to picture Antarctica, you'd probably imagine a white hellscape of ice, wind, and misery. A place where the air hurts your face and survival is basically impossible. But rewind the clock 50 million years and that frozen wasteland vanishes. Instead of shivering, you're sweating. You're standing in a lush, dense rainforest surrounded by palm trees, baobabs, and swamps. This isn't a sci-fi movie. This was the South Pole, and the story of how this tropical paradise turned into an icebox is wilder than you think. If I told you to pack for a trip to Antarctica right now, you'd probably grab your heavy-duty parka, 3 layers of thermal underwear, and maybe a last will and testament. And I wouldn't blame you. It's the coldest, driest, windiest continent on Earth. Basically Mars, but with better gravity and more penguins. But let's rewind the clock about 52 million years to the Eocene epoch. Imagine you're standing in that exact same spot. Instead of shivering until your teeth crack, you're sweating. The air is thick, humid, and smells like rotting vegetation and wet earth. You aren't surrounded by a white wasteland of death. You're standing in the middle of a lush, temperate rainforest that looks a lot less like the day after tomorrow and a lot more like a calm day in New Zealand or the Pacific Northwest. Here's the thing though. You might assume that Antarctica was only warm because it was closer to the equator back then, lazily drifting south while sipping a tectonic pina colada. But you've been lied to. Antarctica has been sitting firmly over the South Pole for the last 100 million years. It didn't move to the freezer came to it. Back in the early Eocene, the world was in the grip of a greenhouse Earth state. We're talking global temperatures that would make a modern climatologist faint. Down here at the bottom of the world, summer temperatures averaged around 20 degrees Celsius, 68 degrees Fahrenheit. That's t-shirt weather at the South Pole. However, paleoclimatologists still argue about just how consistent that heat was. Some models suggest it was a tropical paradise year-round, while others insist the winters must have dipped near freezing. Just enough to be annoying, but not enough to kill the palm trees. And yes, there were literal palm trees. But there was a catch. While the temperature felt like a nice spring day in Seattle, the lighting was a nightmare. Because of the planet's tilt, this lush jungle spent half the year in total pitch-black darkness. Imagine a tropical rainforest where the sun doesn't rise for 6 months. It's biologically confusing, slightly terrifying, and completely true. So, I know what you're thinking. Nice story, bro, but how do you know? Did you invent a time machine, or are you just guessing based on a really vivid fever dream? It's a fair question. Today, 98% of Antarctica is covered by an ice sheet that is, on average, over a mile thick. Trying to find a fossil down there is like trying to read a license plate on a car that's been buried under a mountain of mashed potatoes. To get the truth, we had to stop looking at the ice and start looking through it. In 2012, a team of researchers aboard the drill ship Geology's Resolution parked themselves off the coast of Wilkes Land, East Antarctica. They weren't looking for oil or pirate treasure. They were looking for mud. They drilled about 1 kilometer down beneath the ocean floor, pulling up sediment cores, basically long cylindrical dirt sausages that act as a timeline of Earth's history. Usually, when you drill into polar seabeds, you find gravel, sand, and sadness. Now for the part nobody expects. When they cracked open these cores and put the samples under a microscope, they didn't find glacial debris. They found pollen. And not just the hardy, I-can-survive-a-nuclear-winter kind of lichen spores. They found pollen from palm trees, macadamia nut relatives, and baobabs. Let that sink in. Baobabs. Those are the weird upside-down-looking trees you see in documentaries about the African savanna. Finding one of those in Antarctica is roughly the same level of weirdness as finding a kangaroo hopping around inside a Starbucks in Greenland. This wasn't a fluke. On the Antarctic Peninsula, specifically Seymour Island, which is essentially the VIP section for paleontologists because it's mostly ice-free, we found fossilized leaves, wood, and seeds. The preservation is so good in some Eocene layers that you can still see the cellular structure of the wood. It suggests a landscape that wasn't just surviving, it was thriving. But here is where the picture gets a little blurry. Scientists still argue whether this lush rainforest covered the entire continent, or if it was just a coastal resort strip. The coastal fringe theory suggests the interior of Antarctica might have still been elevated and chilly, maybe even sporting some snow, while the coasts were partying like it was 1999 BC. However, recent computer models suggest the heat was surprisingly uniform, pumping warm air all the way to the South Pole. We also found chemical traces of lipids, waxes from leaves, that tell us about the water. By analysing these ancient leaf waxes, we know the rainfall was intense. We're talking over 1 metre of rain per year. For context, that's wetter than London, though to be fair, a damp sponge is wetter than London. So we have the stage set. A warm, wet, dark jungle. But a jungle is just a garden until you add the animals. And if you think the trees were out of place, wait until you see what was climbing them. If you were walking through this Eocene Antarctic jungle trying to avoid stepping on a baobab sapling, you'd eventually hear something moving in the underbrush. Your brain would probably cycle through the usual suspects for a rainforest. Jaguar? Tiger? Maybe a very lost tapir? But then the creature steps out, and your brain effectively blue screens. Standing before you is a penguin. But this isn't the waddling, tuxedo-wearing, smile and wave boys, majestic floof you see on nature docs today. This is Anthropornis nordenskjoldi, and frankly, it's a nightmare. For starters, it's about 1.8 metres tall, that's 5'11". This bird is the height of an average human man and weighs about 90 kilograms, 200 pounds. If this penguin wanted to, it could look you dead in the eye, slap the trail mix out of your hand, and there is absolutely nothing you could do about it. In the Eocene, penguins hadn't fully committed to the ice-only lifestyle yet. They were exploiting the rich, warm waters off the coast, but they were nesting in forests. Imagine hiking through a fern gully and stumbling upon a colony of linebacker-sized birds screeching in the twilight. But the giant penguins weren't alone. If you looked up into the canopy, you'd see small, fuzzy creatures scurrying along the branches. These weren't squirrels, they were marsupials. We've found fossils of creatures like Antarctodolops, a possum-like animal that scuttled around the Antarctic floor. It looked like a cross between a rat and a teddy bear that had seen too much. These guys are crucial because they prove a biological link that blows the map wide open. But you've been lied to. You've probably been taught that Antarctica is the lonely continent, isolated at the bottom of the world by a ring of treacherous ocean. We think of it as a prison for ice. But in the Eocene, Antarctica wasn't a prison. It was a highway. It was the final crumbling piece of the supercontinent Gondwana. Back then, South America, Antarctica, and Australia were all effectively holding hands. You could technically walk from Patagonia to Sydney via Antarctica without ever getting your feet wet, though you might have to swim a few river channels. This is why the marsupials in Australia, like koalas and kangaroos, are genetically related to the marsupials in South America, like the Monito del Monte. They didn't swim across the Pacific, they took the Antarctic Express. Antarctica was the grand central station of the Southern Hemisphere, funneling species back and forth before the continents finally broke up and ghosted each other. However, the guest list for this continental party is a source of massive headaches for researchers. Scientists still argue whether placental mammals, the group that includes us, dogs, horses, and whales, ever actually made it into the Antarctic interior in significant numbers during this time. We have found a few teeth that might belong to a group of hoofed mammals called litopterns, or maybe even relatives of sloths. One camp says, "Look at the teeth, they were definitely there." The other camp says, "Relax, that's just a weird marsupial that forgot to floss." The fossil record is so sparse that every tiny tooth fragment sparks a 5-year debate in academic journals. Regardless of who exactly was on the guest list, they all had to deal with the elephant in the room, or rather, the elephant in the dark. Recall that for 6 months of the year, the sun did not rise. We are talking about 24-hour darkness for months on end. Yet the forest didn't die. The trees were deciduous. They simply dropped their leaves and went dormant, waiting for the sunrise like teenagers sleeping in on a Saturday. But the animals? They couldn't just turn off. The residents of this dark paradise likely had massive eyes to capture the faint moonlight reflecting off the clouds. It would have been a surreal ecosystem. A warm, noisy, biological rave taking place in total darkness. Think of it like a Las Vegas casino. No clocks, no natural light. Just a lot of weird characters awake at odd hours, doing things you don't entirely understand. It was a biological utopia, a place where evolution was throwing spaghetti at the wall to see what stuck. But as comfortable as the residents were, the landlord was about to turn off the heat. The lush green paradise was running on borrowed time, fueled by a specific set of atmospheric conditions that were about to crash. So how did Antarctica pull off this thermodynamic magic trick? How do you keep a continent warm when the sun essentially ghosts you for half the year? If you turned off the sun over Canada today for 6 months, it would turn into an ice cube faster than you can say timbre. The answer lies in the ultimate planetary heating system, carbon dioxide. During the Eocene, the Earth's atmosphere was absolutely juiced with CO2. Today, we get nervous when levels hit 420 parts per million, ppm. Back then, estimates suggest levels were anywhere from 1,000 to 2,500 ppm. To put that into perspective, imagine the Earth today is wearing a light windbreaker. In the Eocene, the Earth was wearing a thick, heavy down parka, and it was zipped all the way up. This atmospheric blanket trapped heat so effectively that it didn't matter if the sun went down. The heat simply had nowhere to go. But the air was only half the story. The ocean was the delivery driver. Because South America and Australia were still attached to Antarctica, or very close to it, the ocean currents flowed differently. Today we have the Antarctic Circumpolar Current, a massive swirling ring of cold water that circles the continent and acts like a force field, keeping warm water out. It's basically a moat of liquid nitrogen. In the Eocene, that moat didn't exist yet. Warm currents from the equator could flow all the way south, physically delivering heat to the Antarctic coast like a Grubhub driver dropping off a hot pizza. These currents bathed the continent in warmth, preventing sea ice from forming even in the dead of winter. Here's the thing though. When we plug these massive CO2 numbers into our modern climate supercomputers, the math breaks. If you pump enough CO2 into the air to make Antarctica a tropical paradise, physics says the equator should have been boiling hot, literally uninhabitable. But fossil evidence shows the equator was hot, sure, but not that hot. The temperature gradient from the pole to the equator was weirdly flat. Historians and scientists still argue whether our climate models are missing a crucial piece of the puzzle, specifically regarding clouds. The polar stratospheric cloud theory suggests that weird nacreous clouds might have formed over the poles, trapping heat specifically in those regions without roasting the rest of the planet. It's a convenient explanation, but until we invent a time machine to go sample a cloud from 50 million years ago, it remains a heated debate. And then there's the question of where all that gas came from. It wasn't just steady volcanoes. There is evidence of a methane burp, a sudden, catastrophic release of methane hydrates from the ocean floor that kicked off the warmest spikes of this era, like the PETM. Methane is a greenhouse gas on steroids, about 25 times more potent than CO2. This suggests the Eocene wasn't just a stable, warm period. It was a volatile, gassy, chaotic hothouse that was constantly teetering on the edge. The Earth had found a way to cheat the system. It created a lush garden in a place that should have been a freezer. But geological cheats don't last forever. The continents were drifting apart, inch by inch, about the speed your fingernails grow. And they were about to open a door that could never be closed. The Parker was about to be unzipped. The end of the Antarctic paradise wasn't an asteroid impact or a sudden explosion. It was a divorce. Around 34 million years ago, the tectonic plates finally snapped. South America ripped away from Antarctica, opening up the Drake Passage. Soon after, Australia pulled away to the north, opening the Tasman Gateway. This was the nail in the coffin. With those gateways open, the warm equatorial currents, the pizza delivery drivers bringing the heat, were cut off. The Antarctic circumpolar current began to spin up. It circled the continent, isolating it from the rest of the world and locking it in a thermal prison. Simultaneously, something bizarre happened in the Arctic Ocean that changed the chemistry of the entire planet. A tiny freshwater fern called Azolla bloomed in massive quantities, died and sank to the bottom, trapping gigatons of carbon dioxide in the seabed. Now for the part nobody expects. This tiny plant effectively scrubbed the atmosphere clean. CO2 levels crashed. The Earth's heavy down parka was ripped off, leaving Antarctica exposed to the freezing void of space. Temperatures plummeted. The lush forests didn't just die, they were buried. The first glaciers formed on the highest peaks, then spread like a slow-moving white mold. The giant penguins, the fuzzy marsupials, and the baobab trees were pushed to the coast, then into the sea, and finally into extinction. Within a few million years, the green jewel at the bottom of the world was gone, replaced by the white ice sheet we know today. Scientists still argue whether this freeze happened rapidly, in a few thousand years, or if the ice sheet pulsed back and forth for millions of years before settling down. Some evidence suggests the ice sheet collapsed and regrew multiple times, which is a terrifying thought given where we are headed today. Because here is the reality check. We are currently pumping CO2 back into the atmosphere at a rate that makes the Eocene look slow. We are effectively running the tape in reverse. If we keep going, we aren't just warming the planet, we are trying to rebuild the Eocene. But we don't have 10 million years to evolve giant penguins or migrate our cities. We have decades. The Green Antarctica isn't just a cool story about the past. It's a blueprint for a potential future. A future where the ice melts, the oceans rise, and the South Pole becomes a jungle once again. The only question is, will we be around to see it? Or will we just be another layer of fossils in the mud? Antarctica wasn't always a frozen wasteland, and it might not stay that way forever. The Earth has a long memory, and it knows exactly how to turn the heat back up. If you want to know what happened to the weird animals that got kicked off the continent when it froze, hit that subscribe button, and I'll see you in the next one.